Hello. Now we are going to introduce the new concepts and new part of our D flip-flop project, in which we are aiming to do the ILA. This is a integrated logic analyzer, in which it is just like an oscilloscope with the two probes. So just start again. So first I want to discuss the steps which are included in this. Okay. So modify the Verilog code according to the step followed by for VIO. We have already done this. Create VIO as explained earlier. Create an ILA template using IP catalog. Once the template is generated, now click on IP sources, instantiation template, and VIO file, which is a Verilog file. Copy paste the template and make the changes accordingly. Change the module prob name of the ILA template. You just copy. Now your design is ready. So let's start again. New project. Okay. RTL project. This is RTL project and category is general purpose. Package is 236. Speed is -1. Family is RTX7. This is 106. Next. LED element is 20,800. Flip-flop is using is 41,600. And now let's finish. The first step is to change our Verilog code. Actually, in VIO, the output of the D flip-flop is the input of a VIO, and the input of a D flip-flop is the output of a VIO. So just add one file, create a design source. Here we are going to add, this is D flip-flop, dff.v. Now just finish it. Let's change again all the parameters. This is a P clock, output is a ratch, which is not an output. Okay, so it is the input of ILA, right? This is the output of ILA. This is input, and this is clock, and then save it. So first we have to define the VIO part. IP catalog. Just search for VIO. This is the VIO, virtual input output. We are using one probe. Okay. Number of jobs are 4. Highest can be 6, 8, 12, anything. Out of text. Just go to the IP source. Go to the instantiation templates. This is a Verilog file. This is our VIO module. Copy paste this module in our Verilog. This is VIO instance name. Instance name is PC VIO clock. So the input is Q for a VIO and the output is D. Right. Just save this and again click on IP catalog. IP catalog. This is video, sorry. So search for the ILA integrated logic analyzer. It helps to show the waveform and all the order. So number of probes which we are using like D and Q. So it is 2 probes we are using, right? And probe ports is 1 number of comparator 1. Okay. So we are introducing now ILA part. So this is the number of jobs, maximum can be 4. Okay, so the out of context model run was launched. Okay, now the next step is to elaborate design, right? You have to elaborate design. After that, we will introduce the ILA block on our DFF just to see what happened when we do before. Okay, so this is our ILA block. So this is our input output planning. So now we can scale our clock. This is our clock. Input is W5, which is inbuilt, and DFF is LVS33, LVCMOS 33. Let's save this file so that we want this. Okay, PC new VIO constraints. Let's save this XTC file. Now, what to do? Now just go to this ILA part for large IP. Just go to this ILA part. Okay, where IP sources is there. Then ILA instantiation templates. This is our VIO code. Here we have to change and add this module. Just like a black box, the functionality of this is based on the IP which we are using. So this is package, this device, this DFF. Now just add this. Instance name is PC new ILA. The prop 0 is, say, is it D, and the prop 1 is Q, right? Just save this file. Okay, I'll just try to elaborate. Just generate the bitstream directly. So launch file, launch run. Okay, it will take some time. You already know. It's a 1%. Actually, it will take a lot of. Let's see. So this is my FPGA board. This is a Basis 3, which is based on RTX 7. The running the ILA07. This is one. So by this, what we are actually getting that ILA, which is the integrated logic analyzer. We will analyze the input, like when we change the T to 0, the Q will automatically change to 0, and it will be analyzed with the help of ILA. So the waveform will be showed by this eye. Let's see. It will take some time. Have to elaborate. I think. Okay, just wait. Let's see. Synthesis is completed. Okay, so now the part is implementation. So actually, to generate Bitstream, all the steps are done step by step. Like first simulation, synthesis, and then implementation in one go. So just wait for this. Actually, we can see the schematic also after simulation, after RTL analyzing, after synthesis, after implementation also, like after synthesis also. So we try to optimize with the help of the predefined gates inbuilt in this Vivado Xilinx. There are very standard cell libraries also like PDK files and all these things in ASIC. So which will have to analyze or sorry, to optimize the circuit with the least drive strength or the timing. If we increase the drive strength, so assume that if we increase the drive strength, the current is increased. So current is increased, so the delay is less, but the area is increased. The if we increase the drive strength, so it automatically matches the instances which is already there. So now the running optimization design here, you can see. Actually, we have to do this again after introducing the clock wizard, so that we will be able to see the clock. But if we don't if we didn't apply all this clock wizard, so we are not going to see any clock signal in there, because actually what happened that as you know that sampling with itself becomes zero or constant. So actually the clock is sampled with itself, so no clock will be visible on this ILA. We're going to see that. So then we have to introduce the clock wizard. So in that we have to give two clocks, clock 1, clock 2. The clock 1 is 100 megahertz and the clock 2 may be 50, 60, 70. And clock provided by the FPGA is 100 megahertz, which is provided to the flip-flop directly as the module. You know that the module D flip-flop clock, the clock which is directly provided by the FPGA input. It will take some time. This video will be around 40 50 minutes. Take around 40-50 minutes. So the main motive is without using switch, without open or making any changes on the switch, we can directly do this on our screen, on our laptop. So the place design, running place design. And one more thing, in ASIC and in FPGA type, in ASIC basically, we are using behavior code most of the time, behavioral code. So it is useful for us to learn the behavioral style of Verilog. Route design. Just 2 minutes more too long. Let's see. After generating the bitstream, we have to connect our hardware. Then two windows will open like ILA and VIO. If you change the input like if you change the T to 1, then the output Q will be 1, and we can show this on ILA. This is the right bitstream. This is the last part. Let's see. So here we have open hardware manager. Okay. First we will connect this, right? Just open it. So the next step is what? Just open target, which is auto connect. Just auto connect to this FPGA board. Okay. So now we have to program the device. This is XLE450. This is a bitstream file. Program it, and then we're going to see two things. First one is a VIO, and the second one is a ILA. This is a HW ILA, and this is a HW VIO. First, we have to add these two input. 50Q. Press OK. Now you change this to 1. This is 1, so it's working fine. Okay. Now you can see the changes here also, like 1 1. So yeah, this is also changed to 1 1. Let's take another case. If we give the input 0, then this Q also 0, and then run again. This is 0. Okay. So but here we are saying any clock signal, like where this clock signal go. So actually what is happening that the sampling is, I have told earlier that the sampling with the same signal will give us a constant, or we can say 0. So there is no any clock signal. We can add this, there is no any clock signal. So what to do now? So we have to define one clock for sure. Now just close this. Okay. Okay, no problem. Now go away. Now we have to add the IP catalog, which is a clock. What? Clock wizard. This is our clock wizard. We have to add one. Actually, two. Let's see. There is the clock out 1 and the clock out 2. Let's change this to 50. It will definitely show the clock signal now. Okay, and just remove this cross checks, reset, and this. We will now get the clock out, one TK clock in one, which is a FPGA clock, which is also a 100 megahertz clock. So now just press OK. So the customization IP, number of jobs, again 4. From this IP we have to choose the module, which is a clock wizard, and then copy paste it our original file, which is a D flip-flop. Just wait and see. It will take some time, but at the end we will get our clock signal on our ILA. So the completed program or the launch. Okay. And we have to change the ILA. Okay. We have to change the code according to IP catalog, which is a clock wizard. So this is out of date implementation, out of date. Okay. So the out of context module was launched, right? So now what to do? Just close this IP catalog bit. What we have is just close this one. Okay. So this is a D flip-flop. This IP catalog. Just close this. Okay. Now IP source. First we will convert this, recustomize IP. Now we are going to have the 3 number of ports. Okay. The third one is what? The output clock signal, right? And then port 1 okay, put 1 in this. So now we customize the IP, generate again. The background task is running, just close any of this. This generated. And now we have to change and we have to add a what result. It will again take some time. But actually if your processor is good, then it will be fast for you. Let's see. Out of the context module was launched for generating. Just go to the IP source. This is our IP synthesis. This is ILA over all things. Just copy, just paste, just add this IP source wizard. This is intuition lock wizard. Let's copy paste this lock, paste to our main lock, right? Instance name you can PC clock. So the clock one out is okay. Clock two out, just change this clock input. What is this? This is the basic field, the FPGA clock. This is clock, right? And what we have to change, the EUMA, don't have to change this, but here we have to change CLP out to, I think, right? What is this? This is a 50 Hertz. Clock 50 megahertz. Clock out syntax. Okay. And here also. So now we are providing the clock out to the D flip-flop. Now just save this. Okay, we have already changed the ILA clock. No problem. ILA clock. You don't have to change anything else. Just save this and just generate the bitstream. I think. Yes. Now, as you already know that it will take time. Let's see. The step is, you can see the step running ILA synthesis 1. It will take 10 minutes. Just running the synthesis design. Synthesis failed. Shoot. What is the problem? Failed synthesis modality. So we have the duplicate portion problem. You have to change something. The problem is instance ILA. Okay, so actually it didn't change this to 2, right? Save it, run it again. This WC is a customized design, but we have 3 number of input, right? Nope. Just close it and just generate the bitstream. Again, we have to do this. So the last step is the write bitstream, right? So we are waiting for the last step. Here is a 2 error and then 1 into 67. Let's see. Running place design. Okay. There I'm running. This is the previous one using how design is actually going to stuff art. Let's see. It's the right bitstream, the last step. Let's see. This is our basis 3 RTX7 FPGA board. So this is the open. Click on the open hardware manager. Just connect this first. Click on this. Just press OK. So now just open target, auto connect. So now it's connected. So the last step is to program device. This is a Bitstream file. This is a debug profiles. Because we are using VIO, ILA and all these things, the debug file will be there. Let's see. So previously, first just click on first add. Can you add the clock to? Yes, there is clock out too. Just add this clock out too. Okay. There is a clock out. First, just change it to one. The queue is from also must see over ILA. There is a clock out. Just so now the clock output is also there because the sampling is done between two different signals, which is one is 100 megahertz and the second one, which is clock out 2, is 50 megahertz. So now we can see this tree check is 0, Q is also 0, and then run this. Now, so that's all. This is our last topic on ILA, clock wizard and VIO. Now we will proceed further to the higher topics. Okay, thank you. Just close this FPGA hardware. Just